Okay, so once again, we're going to solve a linear equation, and the first thing you want to do is make sure it's in the proper form, and we need to move that x term to the left-hand side so that it is. So if we subtract, we're going to have x prime plus a negative tangent of t times x is equal to the remaining sine of t. And again, we want to make sure that we pick up this entire coefficient here in our integrating factor. So off to the side, our mu of t is going to be e to the integral of the negative tangent of t with respect to t. And again, we could either recognize this as a derivative of a log function, or we could do a substitution. This is the same thing as e to the integral of negative sine of t over cosine t dt. So if we take our u to be the cosine of t, then our du is just negative sine of t, and this ends up just being our e to the integral of negative 1 over u. Actually, it's positive now because of the negatives, du. So that's e to the natural log of u. So that's going to just be our u, which was equal to our cosine of t. So our integrating factor is just the cosine of t. So once again, we multiply that on both sides. So we're going to have our cosine of t times the x prime plus our negative cosine of t times the tangent of t times x is equal to the cosine of t times the existing sine of t. And we all know from trigonometry that tangent's just the sine over cosine ratio, so that simplifies down to just a negative sine of t. So in our next step, we're going to have our cosine of t times x prime plus our negative sine of t times x is equal to cosine of t times the sine of t. Next up, rewrite this as the derivative of a product. So this is the derivative of our cosine of t times x that we differentiate, and that's equal to our cosine of t, our sine of t. And we now need to integrate both sides with respect to t. So we go and integrate both sides. So on the left-hand side, we end up with x times the cosine of t. Over here, you can recognize this as a double angle formula. It's just half of it. So this is the integral of 1/2 of the sine of 2t with respect to t, which we know is going to turn out to be 1/4, and it's a negative of the cosine of 2t plus a constant c. So again, we've got x cosine of t is equal to negative 1/4 cosine of 2t plus c. Last step, of course, is to isolate the x. And so our x of t, when it's all said and done, is equal to negative 1/4 the ratio of cosine of 2t over cosine of t plus c times, and if you wanted to, you could write this as the secant of t. Now that is our solution, but we all know from trigonometry that you could, of course, use the double angle formula for cosine to turn that into sines and cosines to simplify this down further. But this is a perfectly fine format for a final answer as well.